Good morning, sir.
Very good morning, Bhavik. Very good morning. Right. So, what we discussed in the previous sessions about the different types of applications we have discussed. Even we discussed about the presentation layer, business logic, data layer. What are the different types of applications do we have? So, it can be a standalone application, or else it can be a client server applications, web applications, cloud, right? So that part was discussed. Now, today we are going to discuss about the design perspective, design part of the project, because being into business analysis, as in we prepare different diagrams as part of designs, something like use case diagram, sequence diagram, all that. But there will be a role called architect. If you remember when we are working for a project, as I mentioned, right? So as the role of a BE, there will be a role for architect as well. So architects nothing but people who develop architecture for the project. So when we, being a business analyst, we need to have a knowledge over the architectural part. What are the different types of architectures we have, and what are the key and core important elements to be taken into account when architect prepare architecture for the project. Today I'm going to discuss about these things. Normally architecture nothing but roadmap, technical roadmap. In simple terms, we call it as a technical roadmap. So why technical roadmap? Technical roadmap details you how the application has to develop. But this is not something confined to a particular object. For example, if you have taken any organization, let's say, I'll give you an example, right? For example, if you take any organization, yeah. So if you have taken any organization consists of these, okay? So yeah, so if you can see here, the organization consists of these are all different things. Like for example, if you take any organization, so organization will have some business decisions as part of their business activity to be maintained. So they will be taking some business decisions. And these business decisions to be implemented, they require some strategies to be maintained, because whatever the business decision an organization has taken, either for the short-term benefit or for long-term benefit, they required to implement some strategies. To run these strategies or to maintain all these, they required some applications to be used within the organization. Okay. If you have taken the previous case study, what we have taken, for example, a cloud-based point of sale system or something, organization have taken a business decision for business expansion. So as part of business expansion, they have two strategies, two ways, right? So two ways to improve their business expansion. What are those two ways? One, either expanding different retail outlets in different parts of the locality. That is one way. This is how they can improve their business. This is one way. Second, in spite of that, because increasing the number of stores will increase the operational cost, operational investment and operational cost will be. So in spite of that, what they can do, they can go for our online sales. So there is a strategy behind. Means if you are implementing a business decisions in the organization level, they wants to implement some business strategy. For example, they have chosen a business strategy to do online, because to increase the volume of online sales. That's what the strategy they have identified or taken a decision, because this is less expensive comparing to that first one. To make it in reality, what is the required? They may be required one application. For example, they required something like online shopping portal. Okay, some portal, shopping portal, sales portal is required so that customers, they will be branding that customer can buy products online without coming to the store, right? So this is the one way where they want to improve their business. One more way. So they want application or they may be required multiple applications. And to run these applications, what they want some systems. What are the different systems? It may be two, it may be three, it may be 10 systems they want. To manage these systems, to manage these applications, what kind of data, what kind of source they will be using? They will be using some data. Data management is required. And this data will be transformed from one system to another system. For example, customer data you have taken. Customer data is used for different purposes. Customer data is used to know about how much sales happened. For that only customer data you are taking. Which product is moving faster, which product is moving slower, right? So if you want to know also, you require a customer data. Sales is needed. Sales data is needed. So how the data flow process happens from one system to another system. So for example, we from an architect level, okay, forget about the role of a B because that part was done. Okay. Now, if you try to understand the architecture point of view, if you are an architect or if you are a group of architects, you have to create a technical roadmap. So this technical roadmap consists of lot many things. Consists of lot many things. What are all the things are involved in it? For example, you must be knowing about their business decision strategies, all that. So for that, what is required? You need to have an understanding over the business architecture. I already explained what is meant by business architecture. That is needed. Second, it's not only about the business architecture. We must have a clarity over the kind of systems architecture also. Systems architecture means what are the systems are being used within the organization to manage all that. What are the different multiple systems are we using to manage, right? So this is where we call it a systems architecture stands for. Means what are the different systems are we using and how these systems were interconnected. That's where we call it a systems architecture stands for. Next, application architecture. What are the different application? Let's say, for example, if you are developing an inventory management system, as you can call it as an application. This inventory management system, found out by the application, will be used in different areas, right? So if you want to track the progress of the sales against to the products what we have sold. So when you can see that, right? So that you can see the difference in the inventory management system. So how these applications were interconnected, right? So for that, what is required? So an application architecture is needed. Next, data architecture, how the data flow process happening. For example, there is a data relating to inventory data. Product data was stored in the database management system in inventory. The same data is being shared or the same data is being accessed by the biller. Who is biller? Biller, nothing but a person who is billing the products in the counter, right? So he is accessing the data and he is doing it. The same data may be used by a store manager to know about what is the position of stock as of now, right? Is there anything to be ordered from the manufacturer, etc. Let's say, for example, we have ordered it. So we have ordered to the manufacturer the list of products. So that was delivered to us through a supply chain process. It was delivered. So where it will be delivered? So it will be delivered and maintained in the inventory. Now, if you want to know about the stock position, where are you storing? Where are you going through all that? So you will be seeing all these in the inventory management system. So there is a data which is transformed from different parts of the location. For that, what is required? Data architecture is needed. So there are two more levels. One is about business architecture, majorly focusing on what kind of business goals, all that stuff. If you remember last time I have explained that to you. Next, there will be some application architecture. What are the different applications are using within the organization and how these interconnected. Do remember, we are not developing all, right? For example, we are developing an online shopping portal, for example. Okay. This online shopping portal is not a standalone application, is not an individual application. This may be interconnected with multiple applications, right? So, because for example, you want to know about the customer perception, maybe your application might integrate with some CRM or maybe from some ERP application. So, this is where you have to know in what way, being an architect, okay? Do remember from the architect point of view. Being an architect, you need to understand how this was interconnected, right? How this application, for example, you are making some changes in the base level application or you are developing a new application, how this changes or the development you are doing will be impacting on the multiple systems or the application. That's where something which you have to be focused. That's where we call it as application architecture or that. So like that systems, data. This is what we call it as enterprise architecture. So there are two different architectures which we develop in the field of IT. One is enterprise architecture will be developed. Second is solution architecture, two different. If you want to develop an enterprise architecture, you need to consider the business architecture. You need to consider the systems architecture. We need to consider the application architecture. We need to consider the data architecture. So by combining four, enterprise architecture will be developed by an enterprise architect team, right? So it's combination of both business, functional, I can say it can be a technical thing. Okay, so they have to come up with some business architecture, enterprise architecture. So to develop this enterprise architecture, there are two major tools we use. For a very long time, we are using framework. I can say framework rather than tool. I can say framework to you. One of the prominent framework for a very long time we are using called Jackman framework. Jackman. Jackman is one kind of framework we are using for a very long time. So apart from Jackman framework, there is another framework called TOGAF. TOGAF means the open group framework, it's called as. The detailed form of it is this. TOGAF is a framework which is used to develop enterprise architecture for any application when they are using in the when they are implementing a technical roadmap for the project. Now, what is solution architecture then? When you're talking about solution architecture means how solution has to be given. So what kind of solution is something suitable, is desirable at this level to the consideration, right? So by keeping enterprise architecture into account, by understanding the non-functional requirements, because non-functional requirements are the parameters for solution architecture to be designed with. Why non-functional? Because non-functional requirements will tell you the characteristics of an application. For example, we are developing a cloud-based point of sale system. As an example, we have taken earlier. Cloud-based point of sale system is a solution we are going to develop. So cloud-based point of sale system is not only not only we are using cloud-based point of sale system. Even cloud-based point of sale system we are going to develop. So we need to make sure how the application has to perform. So application performance means two things. One is accuracy, second is performance. Accuracy means whatever the results you are going to get must be accurate, 99.99%, right? So you should not get any kind of results. For example, you want to see the status of the products, right? So which are inventory in the store, right? So you should get a accurate number. That's what we call it accuracy. Next, about the performance. Performance means, for example, there were around 300 to 400 people in a day were coming to my store. So billing has to be performed, billing has to be done as fast as it can. Minimum time, average time will be not more than 5 to 7 minutes. Within 7 minutes, if it is completed, so that I can finished off many billings in a particular day. So this is what we call it as performance. So what are all required here? You required performance of the application. You required accuracy also. Next, you required scalability. What is scalability? Scalability, nothing but wherein this application can be used in any environment. That's where we call it as scalability. Means in future, for example, if you want to make some changes, this application should be in a position where you can make changes at any point in time. That's what we call it as scalability stands for. Scalable means this application can be scalable and can make changes at any point in time. That's what we call it as scalability stands for. So this is where we call it as non-functional requirements comes into picture. So non-functional requirements are the base level parameters to develop solution architecture for a customer. Because anyway decided, right? So developing cloud-based point of sale system is decided. How this can be developed? Means if you want to develop the solution, if you want to develop a technical roadmap for this project, for the solution and all. So what are the different elements to be focused on? So implementation, that's where the detailed design comes into picture. That's where generally you need to go for designing perspective, right? So because if you want to know about the architecture, first of all, people should know about the design, right? So design from the technical people point of view, from an architect's or technical people point of view. If they wants to develop any architecture for the project, they need to have a design. For example, designs will be categorized into two different designs. Here you can see designs are two types because when you are going to develop a solution for the project, so low level thing is design, high level is architecture, low level is design. Architecture is what you can see over the screen, but design is the something which you cannot see. Design is internal part of the application. So unless until if you don't have a design with you, architecture development is not something possible. Now, if you want to know about architect system designs and all, you need to have a knowledge over, you need to have a detailed information about the non-functional requirements of the project. That's the reason why whoever is developing an architecture for the project, any people, right? Whoever is going to develop architecture for the project, so they must be taking non-functional requirements into consideration because they never get into functional requirements. That is nowhere related for us. Because application to perform well is the primary motive here. Okay, what features are we going to develop? What functionalities you are developing? It is nothing to do with our as an architect role. It is nothing to do with our thing. Because anyway, that is there, like business analyst team will be there. They will be taken care of what features required, how the color combinations looks like, right? So how the grandeur, right? So user experience, creating some user experience for the customers by giving some color combination. For example, you are creating a HTML page. HTML means, for example, login page you are creating, for example. Login page, simply you require two different fields for user ID, password, login button, submit button, and cancel button, right? So this is HTML page. If you want to have an attraction, what is required? So they may require to use some CSS, which is called cascading style sheets. Cascading style sheets will elevate the login page. Color combinations will be given to that. Grandeur will be given. So that if someone wants to log in, they feel pleasure to use it because it looks and feel will be good. So this is where cascading style sheets are being used, which we call it as CSS in short. So this is implementation perspective on a high level, on a broader level or an outer level, which normally we see, right? So which normally even technical people, user interface designers, or at the same time BA, right? So we are all focusing on the features and functionalities. But when it comes to the implementation of the design or architecture of the project itself is concerned, understanding the low level design or as well as the high level design of the application is the parameter. So for that, what is required? It is nothing to do with functional, it is to do with non-functional, how the application should behave, performance, accuracy, scalability, and after this is even needed. So designs are categorized into, when it comes to the system designs and all, usually system designs will be categorized into two different designs. So one is about the low level design we call, second is a high level design. First I can say high level, second is a low level. That's how it is. High level design is first, low level design is next. What is high level design? A high level design means in this high level design, we need to develop some architectural design. Architectural design for the project, layer of the architectural design, which architect people will be preparing. Right. So this is one part of it, right? So designing architectural designing is one part of core element under the high level design part. That is point number one. Second, distributed systems. Distributed systems means, for example, as I have told you some time back, data flow. Data flow from one system to, for example, customer data. Customer data, or else maybe, for example, inventory data, right? So product status, right? So inventory products, how many products we have. So you want to know that. The same data is being distributing for different systems. The same data you are using in inventory management system, the same data is being used when we are working on point of sale system. The same data may be using by the store manager to know about the stock position so that he or she will be ordering. So how the data is distributing among the systems, the further reason distributed systems is required. If you are going more detailed and all to use this distributed systems, there are different applications. Let's say, for example, we are working on Java. For example, there is a programming language called Java we are using. Okay. For example, right? So Java as a programming language, for example, right? So to develop uh, web-based projects. Okay, for example, right? So to develop web-based projects, for example, Java is one thing we are using. Because if you remember last session, I told you that, for example, you are developing some client server applications. Okay, for example, you are using some client server applications. They use servlets and JSPs to write the code, right? So what are the code they are writing? So everything will be servlets and JSP. This is what something which normally they use. Servlets, JSPs they use for client server applications. Now, if it's a distributed application, okay, if it's a distributed application, there is technology called RMA and CORBA. Right? RMA stands for remote method invocation. We call it as remote method invocation, and CORBA earlier, because most of the Orbix related projects are developing using CORBA. It's very old technology and highly technical technology. CORBA, you hardly find people outside, hardly, because you can count it not even in fingertips. That's how CORBA technology, which is one of the old language, I can say, distributed language, because this is all comes under the distributed languages. Later on, RMA has transformed into Hibernate technology. Hibernate, that's how it was transformed. That's a different story. Corba, majorly Orbix projects. What are the Orbix projects we are going to create? So for all that, generally Corba is a technology which is used, highly technical technology and highly valuable one, but very, very less, you not even on fingertips. That's how it is. It's a whole thing, right? So this is where generally distributed systems. Now, if you want to understand about the distributed systems, how the system data is distributing among the systems are we going to use. This is where generally whatever the technology, right? So either it can be RMA or it can be Corba, right? So all these things are being used. Next, we need to focus on the load balancing point of view. That's where I said, for example, why load balancing? I'll put you this way. For example, we are developing an online shopping portal. At peak times in the weekends, assume that being a business owner, you have decided there will be of more traffic to the system or accessing the server. There will be more traffic. So all of a sudden, if you see, when we are doing some shopping sometime, you may get some error message that server busy, right? So our server down, something like. Why? Because there is more load is being maintained on a particular server. There is a possibility two things. One, server will be busy to access. Sometimes if load is more than the expected, automatically server will fail, server will be down. Again, they have to revoke the server. So for that, what is required? There is a non-functional. This is also comes under non-functional, which is called load balancing. Load balancing means we have to maintain equal load in each and every system. That's the reason if you remember, I'm not sure whether to what extent you have an idea, but for example, when we do when you are doing some share market trading, right? For example, when you are doing some stock trading, etc. Being a user, whenever you have logged in some applications, because I don't say every application will show it. So in some application, it will give you different servers. For example, if one server is busy, right? So you can click on the drop down box, you can select the second server and you can connect. Else third, else fourth, else fifth, right? So different servers they are maintaining. Why? Because more load is there in one system, one server. What will happen automatically? The next remaining users will be tripped automatically. They don't require to use it manually, but I'm just saying you in an example point of view. Automatically, the remaining load will be distributed to the next systems. So that what will happen? Load balancing will happen. Load balancing means they can manage the load properly. That's where generally we have to. So when there is a load balancing, what happen? Performance of the application won't be disturbed. At the same time, application won't be failed, right? So performing and non-performing all that. This is where generally we call it as load balancing comes into picture. So high level design is required. So high level architectural designs and all everything are needed. At the same time, we must be knowing about the distributed systems, all that is required. So distributed systems and all everything is also needed. That is also essentially needed over here. That is required. At the same time, load balancing, nothing but whatever the load are you going to maintain among the servers and all that has to be distributed equally. So load is balancing in a equal position so that your application performance won't come down. It won't because maybe time what you are spending on that to perform, right? An activity by doing won't be having any disturbance there itself. That's where generally load balancing comes into picture. Next, fault tolerancing. One more point, or consistency hashing or fault tolerancing. Fault tolerancing means um, for any problem, because this is where again I have to go back to uh, microservices, because I have discussed with this couple of times with you. Again, I'm repeating to you. Right? It's fault tolerancing. Fault tolerancing means if there is any fault in one particular component, other system and other components should not be disturbed. That was the rule, fundamental rule. Why? Because, for example, if there is any problem uh, in tracking the status of the products what we have purchased online, for example, right? So tracking is the area where we are facing the problem. So maybe you may, because when you are searching Google or when you are searching online shopping, if you see, tracking may have an error. But it doesn't mean that if you want to order goods or if you want to pay online, right? So you don't see any problem with it. Why? Because the problem is only component. The problem is to track the products. Means if you want to know about the tracking of your products, that is where the problem is arising. So if there is any to the corrections to be made, if you can do this correction on that, it's enough. So it won't be disturbed. It won't have any impact on the other systems, other components, because rest of the components can be used by the users usually. This is where we call it as fault tolerancing. Right? Fault tolerancing means if there is any fault in what particular component and all, the other application should not be disturbed. That's the reason why we are working on microservices. Because earlier it's a monolithic. Monolithic means all the components are tightly coupled. If you want to make any changes in one component, it will be impacting on other components might be. So that you're required to do the testing from the beginning. That's how the situation earlier. But now the situation was not that. So the situation has completely changed. Now it's a microservices architecture because for every component, for example, if you have taken ordering goods, okay, or tracking the progress, for every component, there will be a, sorry. So for every component, there will be a microservices will be created as separate. So because of the microservices, what we are creating, a particular component, we are creating a microservice. If you are making any changes in that, it is confined only to that particular one. So it won't be impacting on the other areas. This is where we call it as microservices concept. Nowadays, when we are developing the designs, when we are creating architecture and all, why microservices architecture we are adopting because of this reason, because multiple components we are developing. If there is any problem arised in one component, so you can repair only that. So the other application performance won't be disturbed. But whereas in monolithic, it was not the case. In monolithic, the problem is that again, you have to go back, right? So you have to go back to the testing from the beginning and you have to do the entire testing. So whether where the problem are affected, right? So because of the changes we have made, right? So what are the other components are getting affected, right? So you have to see and you have to correct yourself. So that's a tedious process because earlier there was very less changes, but nowadays the situation is different situation because a lot of changes are happening on the application. So it is highly difficult for us to do it. This is where generally we need to understand about the consistency part. At the same time, we must be understanding about the fault tolerancing. At the same time, we must be able in a position to understand microservices because different components and all, we are creating a different microservices so that if there is any changes to be made, it is impacting only on it. That is one of the core and important element we will be seeing when we are working on the high level design. Next one about the caching part. So when you're trying to understand about the caching and all that, so caching nothing but the kind of files you are going to copy in a storage, because if there is a storage procedure, storage mechanism will be maintained and all. So if you want to store any kind of information, okay, so if you want to store any kind of location information or something of that, right? So this is where generally caching is being used, right? So for example, location information was shared or location information was accessed. Second time, whenever you want to use it, automatically you can see, right? So there are caching files which will be there in the system automatically. So what are the caching files required so that you don't need to remember? For example, you are logging in. Okay, one example, I'm not relating 100%. Um, for example, we are logging into the system. Whenever you are logging into the system, so you have given user ID password. So you are logged in, you have worked on it, you have signed out. Whenever you are trying to use the login password, whenever you are going to username, right? So whenever you are going to username and whenever you have given the particular alphabet, automatically you can get the username there because in your system, not outside, in your system. Not, you don't get this in password because password is security, but username, yes. Because why this? Because there are caching files already stored in the temporary storage. So for example, Raj, right? So Raj Illinois is my username, for example. Whenever I'm clicking on R, automatically Raj Illinois is the username which will be appeared on the system on that particular screen. Right. So if you want, I can select it as my username because I have already used this username earlier. It was used as a temporary file. It was stored in my caching files. This is where we call it as caching stands for. So what are the elements are required for us to do for caching? For example, user ID password, user ID, right? So user ID or user details can be stored as a caching file, but password no, because password unless until you are selecting an option that don't remember, don't want, because then only you can automatically you can log in. Otherwise, every time you have to give the password, all that. So this is where generally caching file solve that. So means whatever the files are we using to access your application or working on your application, if you want to store that the applications and all, Whatever the files in temporary files is being maintained, this is what we call it as caching stands for. That's what we call it as caching. Next caching, the next is transactions, because how the transactions we are going to maintain. So what are the different types of transactions are we going to maintain? So this is all comes under the high level design part. Next is SQL part. Because why SQL? Because SQL is nothing but structured query language where if you want to extract any data from the database. For example, there are different languages we used in the field of IT. Let me write down here. First of all, we use markup language. We use markup languages. I must tell you this first.